Hello everybody, this is Dr. Eldek, and today we have experiment number 5, and it is about the most important device we have in this lab, which is called analog discovery board. Analog discovery board, we have two versions. This is the old version, analog discovery board. It has a USB cable, okay, and has some wires here. Each wire has a meaning, or has a value, or has a job. So this is what we need to know in this experiment. Let me connect it. Okay. Once you connect it to your computer, you need to run a software called waveforms. Waveforms will detect this analog discovery board, and then it will run it. So they both work together. You cannot use analog discovery board without having waveforms. Okay, so analog discovery board, as I explained, it has a coaxial cable on this side. I mean USB cable, and then the other side it has wires. These are the wires here. So you see in the top you have 1 plus, 2 plus, this arrow, V plus, W1, this arrow, T1, 0, and so on. In the bottom you have 1 minus, 2 minus, and so on. So this is number 1. So it has a name. Every wire has a name. Second, or has a label. Second, it has also color. You see this one is orange, this one is blue, black, red, yellow, black, gray, and so on. This one is different from this one. You see, this one is orange also, but it has a white strip. This one is blue with white strip. This one is black, so there's no difference between this one and this one. They're the same. This one here is white. This one is yellow with white strip. This one is black, and this one is gray with white strip. So we need to know what's the job of every one of them. This website is very useful. It has all the information about this board. It has also a lot of videos. There's also a course in Digiland website, digiland.com. So it is useful, of course, if you want to watch them. Waveforms, again, this is a software that runs analog discovery board. On Canvas, you will find these 3 files. The first one is for 32 bits. Second one is for 64-bit PC. And the third one is for Apple. Okay, all of them are running very well. This first one, I believe this is the old version I have, which is work very fine, very fine. As I said, there are different versions of waveforms, but most of them they are the same. There's no difference. Okay, once you run waveforms, you have to go to Digiland folder, and then you hit waveforms and select waveforms. This icon here. You will open this window. Okay, but before you do that, you connect analog discovery board first. Once you connect it, it will detect the board. So let us see, for example, if we have analog discovery board. I mean waveforms. Here's waveforms. Let us open it and then see. Okay, let me open it again. So here it is, Digiland, the waveforms. Oh, come on. Okay. It already detected the board because it is already connected. Okay, and once you open it, you see you have the same window like this one here. And here you have how many devices? You see 1, 2, 3, 4, 5, 6, and also more instruments, 7, 8, 9. So you have 9 instruments. 9 instruments in this simple device that cost only maybe $200 or something or less. Okay, so it is very useful. It is, I believe that you need to write it to buy it. It is very similar to textbook. So here, for example, the first one here is a scope or the oscilloscope. Second one is the arbitrary arbitrary wave form generator. So this is a function generator. It can generate AC, can generate square wave, triangular wave, also DC with variable number, and so on. Voltage is a DC power supply. So DC power supply is to generate, for example, +5 and -5. Only +5 and -5. Cannot change it. But maybe in the new version of analog discovery board, this is the old version. This one is the old version. The new version has the choice to select values. Instead of one, for example, you can select number between 0 and 5 or 0 and -5. But in the old version, you don't have this option. If you need to generate +5 or -5, you can use this one. If you need to generate a DC, but between -5 and +5, you have to use the waveform generator, this one. For example, if you hit more instruments, you see here we have a network analyzer, we have a voltmeter, which is a multimeter, and we have a spectrum analyzer. And the network analyzer is working up to 10 megahertz, which is good frequency. The voltmeter, okay, this means that it works only as a voltmeter. It doesn't work as a meter, or so it doesn't measure current, or doesn't measure resistance, capacitance, and so on. So this is one of the limitations that we have in analog discovery board. But we can substitute for that by using the multimeter, because the multimeter can do this job, which is not expensive. You can buy it for even for $6. You can buy one from Harbor Freight, for example, for $6. So you don't need. It's not a big deal that you cannot measure current or measure resistance using analog discovery board. So these are the equipment that you have in waveforms or analog discovery board. When you click any of this, you will open one of these windows. For example, this is a DC power supply. Look at this one. This is a DC power supply. You will find this simple window here. Once you need to just click this one here to turn on the power supply. So you have a +5 and -5. You see here you have a green light. This means that it is working, +5 and -5. If you want to measure, for example, voltage, you click the voltmeter and you will have two channels here, channel 1 and channel 2, and you have to enable it, okay, to work. So the channel 1 will read voltage, and channel 2 also can read another voltage. You have a wave generator. Once you click it, you have also two channels, 1 and 2. As you see here, for example, in each channel, you have to choose the choice of DC. This is a DC. This is a sine wave, square wave, triangular wave, and so on. And you have two channels. For example, this one is a sine wave. So you need to also define the amplitude for the peak value, and the frequency, and the offset if there's any offset, DC offset, and so on for each signal. This is the oscilloscope, how it looks like. The oscilloscope is used to display signals. So as I explained in the first experiment, you have four devices here, two for DC, for power supply. This is a DC power supply, and this is a function generator that can generate also DC and AC. And you have two for measurements. One is to measure the voltage, which is the voltmeter, and one to display the signal, which is the oscilloscope. Besides that, of course, there is a network analyzer and spectrum analyzer, and also digital stuff that you can use in other labs, like digital logic, like electronics, like circuit, for example, advanced circuits, and so on. If you look at this is the analog discovery board. This is the waveforms here. If I click, for example, voltage here, you see it will open this window here, this little window. And in this little window, let me open something in the back just to select all and delete. Okay, so now let's open this. So you see here we have this DC power supply. Now it is off. If you want to turn it on, here it is. That's it. It is on. And you see it has a green light here. This means that it is on. If I want to turn it off, that's it. You can turn it on. You can turn the power, the negative, for example, off. or on, and so on. That's it. Very simple. Okay, if you want to, for example, open the voltmeter, here's a voltmeter. It will open this window. If you want to disable it, here it is. Enable it, here it is. That's it. So it will measure the voltage. Okay. If you want to open, for example, the function generator, here it is. So this is how it looks like. This is a wave generator or function generator. Then this will, this is the window that will open. Here you have only one channel. Oh. Come on. Okay. So here you have only one channel. Ah, come on. Here it is. Let me open the other. This one here. So you can, for example, select sine wave. Okay, so this is a sine wave. What is the frequency? The frequency is 1 kilohertz. The amplitude is 1 volt. The offset is 0, for example, so 0 volt. So now you see we have a sine wave here. So this is what we need to do. Okay, now we see it is disabled, so you need to enable it. Now it is enabled. Run, this will run it. Okay, so now it's running. So first enable it and then run it. So now you have a voltage which is a sine wave. But where? This is a problem. This is a question, another question. Because now you say you have a positive 5, you have a negative 5, but where? How can I get them? I don't know until now. Okay. If you need to, for example, have multiple channels, you can go here and select channel 2, for example. Then now you have 2 channels. You have 2 channels. So for channel number 2, I want DC. I don't want AC. I want only DC. So I want DC that is, for example, 3 volt. Okay, or 2 volt. Okay, what if I need, for example, 2.5? Type it. That's it. 2.5 volt. Hit enter. So now I have 2.5 volt DC. And then enable it and run. Then now you have channel 1 showing AC or providing AC sine wave, and channel 2 providing 2.5 DC volts. The last one here, which is an oscilloscope, this is to display signals. You cannot use the display. You cannot use the display and the need to run all. You cannot use the display and the voltmeter at the same time. You see here, it is disabled here. When you open the oscilloscope, it is disabled. The voltmeter is disabled. Why? Because the wires that we are using to the voltmeter are the same wires that we are using to the oscilloscope. So that's why you cannot use both of them at the same time. You can either use the voltmeter or the oscilloscope. That's it. So we will explain the oscilloscope later on when we have some devices like, for example, when we have AC signals and so on. But in general, we have in the oscilloscope, we have time. This is the x-axis, and you have channel 1. You see, this is the orange one, and you have blue one, which is the channel number 2. And you can select the offset and the divisions. For example, here you see 2 per division, 2 volt per division. So each division has 2 volts, 1, 2, 3 volt, and so on. You can change that. For channel number 1, it is only 1 volt per division. If you want to compare, if you have 2 signals, you display them using channel 1 and channel 2, you have to make them the same number. So now, channel 1 and channel 2, each division has 2 volts. So each division has 2 volt. This is 2, 4, 6, 8, 10, and so on. And the timing here, this is the x-axis. So each division has 200 microsecond. So between this point and this point is 200 microsecond, 200 microsecond, and so on, a step. And to make it work, you have to say run. I already hit run. And also sometimes you need to automatically set it by auto set. You can just say auto set and it will work. Of course, it is not measuring anything right now, so it may be confused. I don't know what will it will be reproduced. But this is the auto set is very important. It will display the voltage. So this is channel number 1. This is channel number 2. You may notice that channel number 1 has offset here. Does have offset? Yes. You see, because it is moved. If you wanna move this channel 1 down to 0, where is 0? No, it is already 0. Okay. So this one makes 0, for example, 0. I don't want any offset. Okay, here it is at 0. And the channel 2, you make it also 0. So now you see both of them, they do not have any offset, DC offset, but you can move them up or down by this DC offset and so on. So here you can compare the two signals. Okay. So this is how it works. Let us see now what is in the slides. Return back to the slides. Okay. So the next part in this experiment, I explained to you in details how do you use the analog discovery board and waveforms. For example, you see here every wire has a color and a label, as I mentioned before. You need to know what is the meaning of them. The black represents the ground. It's very simple. So it can work with what, for example, it can work with the red, with the yellow, with the white, with the yellow, with white strip. So any one of them. So V plus, which is the red, W1 yellow, V minus, which is white, and W2, which is the yellow with the white strip. So we agree that the black is the reference or the ground. Now, how can we generate positive and negative DC voltage? Then we have to use, in waveform, we have to use the voltage or DC power supply, which is explained before here. This is the voltage, this one. This is the voltage. Once you click this one, then now you can generate positive and negative 5 volt. In the analog discovery board, which wires? The red, okay, is the ones that provide 5 volt. Then when you have 5 volt enabled or produce 5 volt, we will have 5 volt in the red. Okay, and the white will be negative 5 volt. Okay, and both of them, they are working with the voltage. Supposed to be voltage here. I don't know why this is not showing up. So this is supposed to be voltage, which is this one here. Again, with this one, voltage. Okay, or DC power supply. So this one will produce positive and negative 5 volt. So now when you generate positive 5 volt or negative 5 volt, all what you have to do is just open the voltage and enable it. Then the red will have positive 5, the white will have a negative 5. Then if you have to use any one of them with the black, okay, to work. If you use both of them together, okay, so you have the white and red, then the voltage will be positive 5 in this side and negative 5 in this side. Then the total voltage will be 10 volt. The difference between them. Okay, that's it. Now, what about this one here? This is how can we generate a variable DC and arbitrary wave generator. This is using the function generator or wave gen generator. This one here. This icon. So how it works? It works with the yellow and black. The yellow and black is the channel number 1. The yellow with white strip and the black is the channel number 2. So now you have two channels, as I explained before. Channel number 1 is the yellow wire and the black. And channel number 2 is the yellow with white strip and the black. Okay? So for example, as I explained before, the channel number 1 was producing sine wave. So the yellow and black, you can connect it to the circuit. This will give you a sine wave with frequency 1 kilohertz and amplitude 1, for example. Second channel will be yellow with white strip and the black. It was providing 2.5, if you remember, 2.5 volt. Then when you connect it to the circuit, it will give you 2.5 volt. What if you connect the yellow and yellow with white strip together, okay, as a source. So these two wires is a source, okay. Then the source will be the difference between them. For example, if the yellow is 5 volt and the yellow with white strip is negative 5 volt, then the difference is 10. If the yellow is 5 and the yellow with white strip is negative 2.5, then the difference is 7.5 volt, and so on, and so on. If you want to measure voltage with a voltmeter, in this case, measuring and displaying, as I say mentioned before, they are the same. Use the same wires. So the scope and the voltmeter are using the same wires. Channel 1 is the orange and orange with white strip. This orange and orange with white strip, or 1 plus and 1 minus, this is channel number 1 for the voltmeter. Okay, and channel number 2 is the blue and the blue white, blue with blue and white strip. This is channel number 2. So if you connect a circuit, for example, and you connect orange and orange with white strip to a resistor, this will measure the voltage across this one in channel number 1. And if you connect blue and blue strip, blue with white strip to another resistor, this will display the voltage across this resistor in channel number 2. Where is channel number 1 and channel number 2? Here it is. This is channel number 1, and this is channel number 2. The last one here is the scope. And the scope, you just need to press, this is supposed to be the scope icon. Has 2 channels, as I mentioned before, the orange and orange with white strip. So this is channel number 1. And this is channel number 2. And to set it, you have to select the timing. So to check, to select the number of seconds or microseconds per grid, and do the same for channel number 1, C1, and C2. See here, this C1 is enabled. If you want to disable it, you can disable it. You can, for example, if you want to disable channel number 2, you don't use it, for example, then you don't want this one, disable it. And for each one, you can select the offset or and the number of voltage per division. Okay, you can also add a channel. You can add a channel, and you can also add a channel that has the relation between channel number 1 and channel number 2. For example, if you have a resistor and you have a current in the resistor and you have a voltage in the resistor. If you want to find the relation between voltage and current, for example, but in analog discovery board you do not measure the current. So assume that you need to find the relation between voltage across this resistor and the voltage across this resistor, or the output voltage over the time divided, or as a function of the input voltage, for example. Then you can generate a figure or a display that show you the relationship between the output and input voltage. Okay, so the x-axis will be channel number 2 and y-axis will be channel number 1, or the opposite. So this is the end of this experiment. I hope you understand now what's the meaning of analog discovery board and how can we use it with waveforms. So for example, here this question, how many sources and measuring channels you can use in analog discovery board? Of course, measuring channels, we have 2 channels, orange with white strip, and blue with white strip. So channel number 1 and channel number 2. So you have 2 channels, okay, to measure voltage and to display, to work with the voltmeter and to work with the scope. How many sources? Of course, you can, for example, you can use the white, for example, as a negative, white and black as a -5, and red and black as a +5. You can use yellow and black as a channel number 1 of the wave generator, of the function generator, and yellow with white strip and black as a channel number 2. Then you have 4 now. Okay. Also, you can have red and white. Okay, like this is a 10 volt. You can also use yellow and yellow with white strip. Okay, so you have 6 choices. You have 6 choices. Okay, but of course, how many you can use in one circuit? You cannot use all of them, of course, but you have 6 choices here. How can say here the steps to generate or to generate 5 volt? How can you generate 5 volt? You can generate 5 volt by turning on the voltage. Okay, enable the voltage and then use the red and black. This will generate 5 volt. You can do the same. Okay, there's two ways. You can do the same by what? By connecting, by using the wave generator, and also set the voltage to DC, the type of voltage DC, and set the number to 5 volt. What about the 10 volt? The 10 volt, you can use the voltage and use the red and white. Red and white. This will give you 10 volt. Or you can also use a wave generator and use the yellow, set the yellow to be channel number 1 to be positive 5 volt DC, and the channel number 2 to be negative 5 volt. Then in this case, the yellow will have 5 volt. The yellow with white strip will be negative 5 volt. Then the difference is 10 volt. How to generate 2.5? You can generate 2.5 or 7.5. You must use the wave generator. You cannot use the red and the white. Okay, so 2.5, you can use channel number 1, for example, and set it to DC and its value to 2.5. For 7.5, you have to use 2 channels because it is more than 5. You have to use, for example, channel number 1, make it DC and make it 5 volt, and channel number 2, make it DC and make it its value negative 2.5. Then the difference between 5 and negative 2.5 will be 7.4.5. And in this case, you have to use the yellow and yellow with white strip as a source. These are the 2 terminals. How to generate AC signal of value 2.7 sine by t. For example, how can we do that? Let us see, for example, if we want to do that using the waveforms here. So here it is. We need a wave generator to do that. How can we generate 2.7? So channel number 1, I select sine wave. See, sine wave. And then what is the frequency? The frequency is what? 1000 by, you know, the frequency is 2 by f. You know, this is supposed to be sine 2 by f. F is the frequency. So if 1000 is 2f, because you have already by here. Okay, so again, this one here is what? Is 2 by f. So what is the frequency? The frequency is 500. The frequency is supposed to be 500. So now let us return back to this one here. Let's turn off this. Okay, so I will set this one to 500. The frequency is 500. And what is the amplitude? It's 2.7. Let us see. 2.7. Currently it is 1. You see here is 1. But if you want to change it to 2.7, of course you don't see here 2.7. Then you need to write it 2.7 volt. As you see here, now the maximum is 2.7 volt. This is here somewhere. And then you enable it. You see, enable and run. So now it's running. Now you have channel number 1 showing what? 2.7 sine 1000 t with the frequency 500. 2 by time 500 will be 1000 t. So this is channel number 1. So this is the answer of the or number part C. How to measure the voltage across resistor? To measure the voltage across the resistor, you have to use voltmeter. Okay, like this. And then you connect orange and orange with white strip to the resistor, across the resistor. This will measure the voltage across the resistor. Very simple. So you have a resistor, it has 2 terminals. Okay, connect orange and orange with white strip to across this resistor to its 2 terminals. This will measure the voltage, and this will show up in channel number 1. If you connect blue and blue with white strip, this will show up in channel number 2. Third one here, or number E. If you want to display, you have to go to the scope. You have to go to the scope to display voltage across resistor. Then in this case, you have to one channel only. Then you don't disable, for example, channel number 2. I don't want channel number 2. Then you connect the orange. If I'm using channel number 1, orange and orange with white strip across the resistor, and then open the scope and auto set it and run it. This will show the voltage across the resistor, how it look like. So this is I believe everything about this experiment. See you in the new experiment number 6. Thank you very much.